Hi, my name is Oscar. This is my presentation for the HUD-Mirror, which I developed in the class TDDD27 Advanced Web Programming at Linköpings University. On a mirror, and this is also known as a smart mirror. You can see a picture of one of those on the right here. Smart mirror is pretty much just one of those mirrors that is a one-way mirror, ones you might know from interrogation rooms, where you can see through it from one side, but the other side is just a mirror. If you put a screen behind one of those, you can project information through the mirror. So what kind of information might you want to show? I developed components that show weather, time and date, your calendar, some kind of message, and news. So I'm gonna give you a little demonstration of how it works right now. So here is what my interface looks like. Up here I have the weather, and here I have news. Here I have the date and time, and here is the schedule, and right now it shows a schedule for a classroom at the university. And here I give you, as you can see, the weather information I'm getting from the Swedish weather service, ASMHI, is not quite correct. We don't have negative wind speeds because they, when I use their API, so I haven't managed to find a way to parse it so I get the right information showing up there. I'm gonna look into that later. What's cool about this mirror that a lot of smart mirrors don't have is that it has face recognition. So I'm gonna bring up a picture of myself here so you can see me here. I'm gonna hold up a picture of one of my roommates and see what happens. So there you see the changes. It says it removed the calendar because he doesn't have a calendar implemented. And the weather changed to a place called Jönköping, and the same news are shown. So if I take him, it's gonna go back to me. There you go. And now if I hold up a picture of one of my other roommates, I'm gonna see what it says. So it tells you that no one in my database looks like you. And also, if no one is front of the mirror, all the information except for time and date. You might notice there's a lag, and that's because it takes a picture every. Okay, so that's how it works. There's also a settings page down here. If you click that, you can set up a new user, so you enter your name and what city you want weather for, what newspaper you want the RSS feed from, and what calendar you want to show. Right now, is there only one newspaper working, and that's a Swedish newspaper called Dagens Nyheter. But the plan is to be able to implement several ones. And also, you can only have one calendar at the moment, but I also want to expand this so you can add several calendars and like merge them into one. If you click here, the application will take 10 photos of you in different angles, and that will also be saved as part of your user. And then if you click the add user, he will send this as a JSON to the back end, which will take care of setting all of it up. So that's all of my application. And now we're gonna look a little at how I managed to do this. So I'm gonna look at the calendar component, just as an example. All of the components are pretty much doing the same thing, which is pretty nice, so you can just follow a pattern on how to implement them, but they just show different data pretty much. Okay, so in the base I have a component class. This complement class creates a variable of the model class, and the model class is pretty much a template which tells the complement class that if you want to create an object from this class, then this object needs to hold all of these values. So these are the values that each calendar object holds. So the component makes a call to this service, and the service is where the calculations and such are done. The service in this component is just doing a post call to my backend, and in this post call it sends the URL for the calendar, sends that to the backend. And then when it gets back, it will hold a model like this and send that back to the component. So you can see here that this component is set up to call update calendar every 60 seconds, and when it calls, that's the method in the service that gets called, this method, and then this method does is looking at when the face recognition sees someone seeing that no one is in front of the mirror, the URL will change from there. So it has a subscription to the URL string, and when it changes, it does a new call with this new URL. So this is pretty much how all of my components work, but they of course have some like different tweaks, but in the end that's pretty much what it boils down to. So the face recognition is done like this. I have a front end which has an npm package called ngx-webcam, which is developed by Bast314 at GitHub. So a big thank you to him. This webcam module takes a picture every 5th second, sends this picture to the backend, and the backend does some stuff and gets back a name. So in the backend I have an npm package called face recognition, who justadudewhohacks at GitHub has developed. That's gonna drink a little, excuse me. So the backend has the ability to build a database of all the pictures which are in it, and also when it receives a picture, it detects the faces in the picture, so it pretty much cuts out all, and then it takes these faces and does a prediction on those, and then sends the name that the prediction predicts who it is, sends that back to the front end. So how does this look like in code? Let's see. So this is my front end for the face recognition. And here you can see I have an interval which is taking a photo every 5th second. Calls the trigger snapshot, which takes a photo, and then excuse me, then this photo is sent to the backend through the face recognition service. As I told you, most of the components are built the same way, so also this component has a service which just posts the data to backend. And when it gets a response back, it updates the what name is in front of the computer, so that other modules can see who is in front of the computer and update their information accordingly. And that's pretty much how that one works. So how does it work in backend? The backend works so it gets an image, saves this image to to a path with a name, and this is where it saves it. When it's done saving, it does a callback and loads the image that it just saved. Then it does the face detection, which I told you about, so it crops out the face. And then on this face, well, at first it checks whether there are any faces found or not. If there is, it takes the first face found, because I haven't figured out how to work with multiple faces at the moment. Then it does a prediction, and the prediction is pretty much done the way that when the database is built, the pictures have been modified in such ways so they only shows contours and stuff like that, and then the same thing is done to the new picture, which you're supposed to compare it with, and then it takes the Euclidean distance between the saved, the database photos and the compare picture. So if this distance is bigger than 0.6, then I don't think it's a close enough match to be able to tell the person in front of the mirror that this is who you are. So then I just tell the person that this person is unknown, because even if a person is not in the database, it might still get a match, but this might be a false match, and then the value is usually bigger than 0.6. If it's lower than 0.6, then the prediction will give a name, and this name will be sent back to the front end. So how is the database built? The database is built every time the application or the backend starts. It is also built every time you add a new user. So when you click the Add User button, then the database is built too. So I will create an array holding all the names of the users, which I get from the JSON, which is also sent when the users are added. Then I send a JSON with all the information, and this is saved in the backend. And then when I want to store it in there, I read this JSON file and I run this function that just loops through what names are in there, and then it saves that to this array. And this array is used when I build the database. So here I look at all the pictures, and I'm gonna map them so that when the names are compared, the faces, they have names. The name of the person in the picture is stored as the name of the picture, and this name is compared to the name in the class names array. So when it down here adds the face to the recognizer, which is what does the prediction later, it pairs the name of who's in the image with the name of the names that it's able to tell in the prediction. It's able to tell who is the person by name. So it is doing let's see here. It's using 9 pictures for the training. I have 10 here, but I wasn't sure it was using the 0, so that's why I did 9. And it uses these to train the database, and those are the ones added in the database, and those are the ones that are used in the comparison later. So that's pretty much how the database is built. I'm going to show you what happens when the calendar is called. So this is the post call for the calendar, and it receives a URL through the body, and then it creates 2 temp variables just to see what date the date of today is and what month it is. And then this array holds all the month names. So up here I have a month days, which holds how many days there are in each month, and then I have a days array which just holds what day, well, yeah, all the days of the week. So it does a API call to a URL, not this one, but a similar one, and it loops through all the data which are stored in the URL, all the data I get back from the API call. First, the data in a calendar model, so it looks the same. So when I send it back to front end, it will know what kind of object it is. And then it sees that, or it checks if this object created, it has the date of today's date, and the date is also in this month. Then it will be added to an array called today array, and if it's then it will be added in an array called tomorrow array, because I'm only showing the information of the calendar for today and tomorrow, because if I would have all the information in there, it will be like jammed up with information, and a lot of it wouldn't be like really interesting, because it's like things that happens in 2 weeks, and I'm like, I don't care about that at the moment. And then I sort them depending on starting hours, so that the ones that are in the morning gets shown at the top, because that's smart. And then I check whether they are longer than 1 or not, and then I send it back to the front end. And this is also pretty much how all the modules work when they do their API calls. So sure, the data is parsed a little differently, so when you grab it, you might have to do a little differently, but it's pretty much the same structure in how to collect the data and send it back, and then back. So I'm also just gonna show you my home component, and this component is the component which updates the information depending on who is in front of the mirror. So this one reads in the JSON that is saved in the backend, and so this component knows what information each user holds. And as I told you before, the face recognition is setting up who is in front of the computer right here in the response. So it tells app who is in front of the computer, and then this guy, the home component, he takes so he subscribes to that response and takes the name from there, see who it is, grabs that from the user JSON, and then he updates the information for the other components. So the calendar gets updated with a new URL, the city for the weather gets updated, and the newspaper URL gets updated. And this is if the person in front of the mirror is known. Otherwise, it's just set to an empty string, so the components can handle the fact that no one's in the front of the mirror, and if an empty string is returned, then they are told to disappear from the mirror. So I think this pretty much. I hope that you liked it, and well, leave a comment or give me a like or something. Looking, and have a great day.